Welcome to jnn.com. In this session, we will discuss about literals in the C language. Literals in C language. We know literals are tokens only. Literals are tokens only, that we know that. And literals are also called, we can say these are called constants here. Or in any programming language, literals are also called constants. That means these are fixed values in the programming. Fixed values, or we can say hard-coded values. Hard-coded values within the C program. Within the C program or C code. Okay. So these are about the literals. Generally, if we compile this code into the assembly code, and after that it will be converted to the binary code. So these memory locations are whatever the literals we are writing within the C code are occupying some memory locations, but those are not referenced, and those are not accessible to modify the content, to modify the data inside the memory locations that wherever literals are stored, like that. Okay, so we'll write a sample program so that we can easily understand how literals look like. New C. So leave about all these things. Void main. Yeah. So if you write int a is equal to, let us suppose 10. So 10 is called a literal. It is a constant here. It cannot be changed throughout the program. This literal cannot be changed throughout the program. We can say this is called hard-coded value within this C program. This is called a literal. Okay. So literals are generally 4 types are there. 4 types of literals. So one is, you can say, integer literals or whole numbers. These are integer literals. And second one is floating point literals. And third one is character literals. And fourth one is string literals. So there are generally might be defined in more categories, but in general these are only 4 types of literals are there in the C language. So those are called integer literals and floating point literals. You can say these are called numbers. Okay, number literals. And this is about, you can say these are called text. Okay, in terms of okay, if it is a single character, that is called character literal, or a group of characters if that is enclosed in a double quotes, that is a string literal. We will discuss one by one while writing the C programming. Okay, now take this. This is called integer literal. Okay, integer, because this is a whole number. This is called integer literal. So there are in the integer literals also, we can say there are 4 types of integer literals are there. Okay, so this is actually in different formats. We can write in different formats, like let us suppose one decimal integer literals. That means these are base 10 format. We can say these are base 10 format. Base 10. That means the numbers from 0 to 9 it will be available. Okay, 0 to 9 we can say. These are the numbers that we can use to represent this decimal integer literal. And the second one is octal integer literal. Octal. Okay, these literals are base 8. You can say base 8 format. Okay, base 8 number system. Okay, these so in the base 8 number system, the allowed numbers are only 0 to 7. 0 to 7. And if you represent in terms of base 8 format, the leading letter with leading 0. So compiler can recognize this is in a octal format like that with leading 0. Let us suppose we can write like this: int b is equal to 0, 7. Okay, it will be compiled. The allowed numbers are 0 to 7 only, but leading with 0 value. Okay, leading with 0. This is called octal literal. Okay, octal integer literal. We can represent in this. This is called decimal integer literal. And we can write these integers in the binary format also, or hexadecimal format. Hexadecimal literals, hexadecimal integer literals. This is base 16 format. Base 16. Okay, leading with leading digits are leading with 0 small x or 0 capital X. Okay, after that you can write the numbers allowed digits are 0 to 9. 0 to 9. After that A, B, C, D, E, F, like that. Okay, so 0, 1, 2, 3 up to 9, and after that, so 10 will be represented as A, 11 will be represented as B. Okay, 11, 12, 13, 14, 15. Okay, 0 to 15, that means 16 digits are there. Okay, base 16 format. We can represent like this. In the code also we can represent as like this: int c equal to 0x a, we can write like this. Okay, or int d equal to 0 capital X small a or capital A, you can write any one. Okay, this is about hexadecimal integer format. Hexadecimal integer literal format. Okay, we can represent like this. And fourth format we can write as binary format. Every integer or everything will be converted into binary only, but it will be converted as ASCII code finally while compiling, after compilation. So we can write in any format, it will be converted to the ASCII format. So fourth one is binary integer literal. So this is starting with, means it has only base 2 system, that means only 2 letters are there, and here it has only 2 numbers are there, 0 or 1. 0 or 1, only 2 digits are there, we can say 0 and 1. Okay, leading with small b, 0 small b, or 0 capital B. We can use like this. Okay, these are in a binary format. Sorry. So we can write the system here. Int e equal to, you can write like this, 0 b. Let us suppose we would like to write 100, that is 4. Okay, this is binary integer literal. Okay. You can write okay, with capital B also. Int f is equal to 0 capital B 100, like this. Okay, we can write in both ways. Okay, this is about integer literals. We'll try to compile this program. If there are any errors, we will check it. Okay, gcc demo.c. Okay, it is successfully compiled. We have not written any printf statement, so there will be no data output to the console. Okay, so this is about integer literals. And if you come to the floating point literals, so this is also we can represent in two ways, like in decimal format. You can say one is in decimal format, and second one is in scientific format. Scientific format. Okay, so decimal format means with the number with the decimal point, like that. And with scientific format means it will be expressed as like significant. We can say like this, significant, and e or capital E, whatever it is, and exponent, like this. We can write like this. This is the format, scientific format, or we can say this is, we can use capital E also, like this we can use. Okay, this is the formats that we can follow to express floating point numbers in scientific format. Okay, fine. So we'll check these two also. So float is the keyword. I will explain about the data types in the upcoming sessions. So for now it is the floating point numbers. The keyword is float, and float, let us suppose f1 equal to some 3.1, or you can say we have write pi is equal to 3.14. Okay, if you don't put any decimal point, it will be okay. Without decimal point, it will be treated as a integer literal, and there will be typecasting. So it will be, while copying to the pi variable, it will be converted as a floating point variable. But for now we are discussing about floating point literals itself, so definitely you have to put 3 point or something like that. You can keep 0 or whatever the decimal point it is, whatever the fraction it is. This is about decimal. Okay, decimal floating point number or literal. Okay, we can use this one also as in a scientific format, also in the scientific notation, like pi 1, okay, or pi 2. You can say this is pi 1. Pi 2 is equal to 3.14 e 10 power, that is 10 power, right? 0. Okay, we can write like this. Or in a capital E also, you can name it as, we can write as with capital E also, pi, okay, 3 equal to 3.14 capital E 0. You can write like that also, or you can write 0.314 into 10 power 1, like this. Like this also you can write. Okay, fine. I have saved it and try to compile it. Is there any errors? Then it will come. So no errors. Fine. Now this is about the floating point literals and character literals. Okay. So character literals generally it is a single character that will be enclosed with single quotes. Only one character. Okay. One ASCII character enclosed with the single quotes or within the single quotes with the single quotes. Okay, this is about the char literal. We'll see here. So let us suppose the keyword is char c1. You can say c1 equal to, with the single quotes we can write it. It is empty character and we can write small a like that. This is the char literal. Okay. Character literal. And we can write escape characters also, like char c2 equal to, like if you want to keep escape characters, okay, backward slash n, you can type like this. Okay, this is about escape characters. Escape char. Okay, char literal. And if you want to write in ASCII code also, it is also possible. If you want to use directly ASCII code for this character value, you can type like this. So slash backslash x, like let us suppose 61 is the ASCII value, hexadecimal ASCII value for small a, like that. Okay, this is ASCII code, ASCII hexadecimal char literal. Okay, like that we can write it. Fine. Save it and compile it. Is there any errors? Yeah, no errors. And come to here. And yeah, one more it is string literals. So string literals means one or more characters. One or more ASCII characters. ASCII chars will be in the within the enclosed with double quotes. Okay, double quotes like this. So this is string, whether it is empty character or you can say, suppose char name equal to, this is array we have to represent in terms of array. Okay, in the double quotes we can write it, let us suppose j9. Okay, like this. So this is about the char string literal. Okay, this is the string literal. Okay, fine. Now just compile it. So okay, there are no errors right now. So if you want to print it also, you can print it. That's not a big deal. And yeah, this is about the session for now, about the literals. Okay, we will discuss operators in the next session. And yeah, this is about the literals. If you like this video, so please like it. Just press on thumbs up button and share this video to your friends and subscribe to my channel for more upcoming videos. Okay, thank you.